Good morning, everyone. Welcome to the Lightning Talks. I think that you all already know from yesterday how this one works. We have 15 minutes of talk, 5 minutes of change to the next speaker. And this morning we are going to start with Martin Beer and Let's Fix the Internet.
Hello? Good morning. I'm going to jump right into it so we don't lose too much time. Quickly, you all know how the internet was developed, and basically it was built on trust. It was assumed that every computer on the network is safe and is trusted, and we know who the administrators are, and there are no bad people on the internet. And so the protocols that were developed were basically developed with that trust in mind, and it was assumed that if you send an email, you can trust that email. If you send any kind of message or any packet, they're all safe and don't do bad things. And as a result, now we have to deal with spam, denial of service attacks. We have problems with cookies. They're being abused. They're so bad that the European Union made laws to protect the general public or warn the general public about how bad cookies are to try to protect them. We should have done much better than that. IoT made things even worse. Most IoT devices are hopelessly insecure, can be easily hacked, and can be abused for whatever. And really, if we want to have secure IoT devices, we need to block them from being able to access the internet. That's really the only way to make them secure. Is anyone here not familiar with the OC model of networking? Just briefly, the bottom two layers are hardware. Network layer and transport layer are mostly in the kernel, and then the other layers, transport layer, session layer, presentation layer, application layer, are all somewhere in the application. So basically, any application that you're running on your computer that wants to do things on the network is working on these 3 to 4 layers at the top. And so any application can do their own network connections. And most importantly, every application is responsible for their own end-user identification. Emails, again, is a good example. Mail servers don't identify who is sending or receiving emails. Only your mail client is trying to identify that. And email addresses are not trustable because they can be faked. And if you sign emails, if you have signed emails, then your mail client can verify that this email is actually genuine. But a mail server and any intermediary cannot do anything. And so basically they have to allow every message through because they don't know whether it's genuine or fake, and only the recipient can really 100% sure decide whether this email is genuine or not. I mean, there are guesses about how to detect spam, but these are guesses, and sometimes those guesses are wrong. The only person that is really sure is the recipient. So how do we get out of this mess? The idea is we put user identification first. We create an operating system that allows apps to be built on a user-first paradigm as far as communication is concerned, so that the applications don't open their own internet connections, but let the OS deal with that. So this is where Elastos comes in. So Elastos is an operating system that attempts to address this problem. It's a complete set of C, C++ APIs and frameworks. They even rewrote the complete Android framework and runtime in C++ so that you can build applications in C++, in Java, or in any scripting language and then take advantage of the features that the operating system provides. It's a distributed OS runtime with end-to-end security across a peer-to-peer network. And it's built for containers and virtual machines, and it's using blockchain for authentication. So let me explain how that is supposed to work. So basically, the idea is that the operating system is taking over the transport session and presentation layers. And it's taking over user identification. So instead of a program like a mail client opening up an SMTP connection to another mail server, the client will ask the operating system and say, I want to send a message to a person which is identified by some key, and then the operating system will go out and try to find this person using the peer-to-peer network. And then once it found it, it will, on the recipient side, will ask for permission that there is this identity here who wants to send a message to that other identity, and then the recipient needs to first acknowledge that they want to have a connection with this sender, and only after this authorization happened, the mail client is actually allowed to send their message. They will be given a socket of some kind and then say, okay, here, now we've established a connection, and here you can send your message through. So basically, user identification is handled at the operating system level, and then all applications can take advantage of it, and the applications themselves can no longer connect to the network on their own. Basically, they have to ask the operating system for permission, and that way we essentially solve the problems that we've been seeing, because we're preventing apps from making their own network connections, and so we prevent spam, DOS attacks, worms, viruses, and what have you. A little bit about the history of this project. This project started in the year 2000 in China to build a smartphone operating system, and then it was eventually outpaced and overrun by Android and iOS, so they didn't get finished in time, or weren't able to attract any clients or customers to use it. They restarted in 2012 with a focus on IoT. At that time, they received $30 million of funding by Foxconn, and Foxconn wanted to build an operating system for themselves, for mobile phones, for IoT devices. And they managed to get something done. We got Elastos running on a phone, on some of these devices, basically in beta state. It's technically working, but of course, still more testing needs to be done to make it workable for the end user. Then last year, we started to add the blockchain to the platform. So the idea here is that a blockchain is a potential solution for the identification of users in the system. So we put IDs for people also for applications and for data onto the blockchain, so that we can verify that when you're running an application, that it's the same application that you've been running before, or that somebody else is running, that when you are getting a message from an ID, then you can verify that it is the same ID every time. Technically, it doesn't have to be blockchain to solve this problem, but this is the chosen solution at this point. And so it enabled Bitcoin investors to fund the project, and received a few million dollars out of that. And so that's what we're working on now. The runtime is essentially finished. Now we've implemented the blockchain layer. In this coming 2 months, we're working on the peer-to-peer networking layer, and we will work on the runtime to sometime in summer. I hope that we will be ready for developers to start developing applications on the platform, and of course we're also always ready for contributors to work on the operating system itself. Yes, okay, I'm pretty much done. I have a few references that you can look up when you download the PDF later. Are there any questions? Yes? How to be anonymous in the system? That's a very interesting question. So this question has been come up in previous talks. How does an identity get onto the blockchain? That basically hasn't been worked out yet, so we're still figuring out how to actually get this system started. My personal idea is that there's probably different ways how you get an ID, and in the end effect, even an ID on the blockchain is just some cryptographic key. And so as long as no person itself is attached to that key, you are anonymous. You see similar things with, I think in Freenet and other systems, where your computer will just generate a key, but nobody knows who the person is that is actually connected to that key. So you are essentially anonymous. So the question of how to be anonymous is really how you get that identity. And if nobody verifies your passport with that identity, then you're essentially anonymous. And if you don't put any personally identifying information into that identity, then you're staying anonymous. But once you have established communication with somebody, you can always verify that the next message is coming from that same anonymous identity. Yes? Okay, I said I can block out spam and attacks, and you're asking about other things to block out. What? Well, the side effect is that you can essentially no longer broadcast stuff easily. There's supposed to be a way to build websites or something like personal pages into the system. I don't know how that's going to work. I think what's going to happen is that the recipients, the readers of that site, will have to make a request to read the site and then allow the site to send messages to your computer. But this hasn't been worked out yet, so I don't know if there are any other side effects that we haven't considered yet. Yes?
I don't know if I understand it well, but from what you are saying, the system is quite close, because the only way how to, for example, pass these messages from one guy to another one is that both of them will your system installed. So how do you plan to, how do you want to integrate with the rest of the world, which use all this shitty stuff?
Okay. Yes, the system is closed, and the way you integrate is by installing it onto a computer where you still have other stuff running. So it can run as a standalone operating system, but we're also building it as an application that you can install into your mobile phone, and then you run it. So you have like a sandbox, you have a container where this thing is running, and then you have other containers, or you have the rest of the operating system where you still have your old stuff. And my hope is, or the hope is, that eventually you're going to use the other stuff less and less and less, and then everybody has this thing installed, and then it's quasi-native, and then eventually it is really native. Okay, time is ending. I just want to point out, if anybody is interested in blockchain projects, we have a blockchain buff at 2 o'clock. And I'm hosting, or we are hosting, a blockchain dev room at the Hong Kong Open Source Conference, and we're interested in getting projects to present there. And lastly, this is about me. You can hire me for development, community consulting, CTO services, and web development. Thank you.